Then coming Tuesday, you can't attend the lectures, no? Or you can? 29th.
I don't think so, sir. Pata.
No, sir, I can't. I have a double paper next day.
Okay. So coming Tuesday, there won't be lecture. Only it will be for Ohm.
Yes, sir.
Refraction of light at plane surfaces. Because Ohm, for you, that first chapter also I can revise. No?
Yes, sir.
Write the heading, fourth chapter, refraction of light at plane surfaces. What is meaning of reflection of light? Rebouncing back into the same medium is called as reflection of light. Hello?
Yeah, sir.
When ray of light is incident on reflecting surface, it returns back into the same medium. This phenomenon is called reflection of light.
Yeah,
Yes,
sir.
sir.
Right, like this. When ray of light is incident on plane reflecting surface, then it returns back into same medium. This phenomenon is called as reflection of light. Copy. Can I clear this?
Sir, 1 minute. Done, sir.
What is this perpendicular drawn called as?
Incident.
No, that is called normal. This one is light made to travel towards the plane surface is called incident ray. This is called reflected ray. So normal, incident ray, this is reflected ray, angle made by incident ray with normal is called as what? Angle made by incident ray with normal is called as what? Angle of incidence. And angle made by reflected ray with normal is called as angle of reflection. Angle made by incident ray with normal, reflected ray with normal, they are same to same. Bro,
Yes, sir.
what is angle of incidence? Angle.
Angle between the normal and the incident ray.
So can I say angle made by incident ray with normal is called as angle of incidence. And what is angle of reflection? Angle made by reflected ray with normal is called as angle of reflection. Please copy diagram and these two definition. Very simple chapter it is. The first section we did work, power, energy, force and machine. That is mechanics. Now we are doing light. Then seventh chapter is sound. Then eighth chapter, ninth chapter is, and 10th chapter is electromagnetism. Then heat, then modern physics. So this is in light section. There are 3 chapters. Refraction of light at plane surface, then prism and lens, then spectrum.
Sir,
Huh.
in the last year when the omissions made, were there big omissions in physics?
No, last time it was many. Now you don't have any omission.
So there might be omissions. So what
There
my
might be. There still it has not come now. So we will do everything.
Okay, sir.
But I don't foresee that they will omit because your schools and everything has been started on time.
Yeah, sir. But the thing is, as due to online school, they might cut it off.
They might. Yes, they might. Definitely they will cut 20%. But they cut in such a way that anyhow that is not that important. I think one full chapter they may cut.
Okay.
Done, sir.
How many types of medium are there?
2.
Two. Which two? Rarer and denser. Rarer and denser. Speed of light in rarer medium is larger and in denser medium it is smaller. Laws of reflection. First we will see. First, angle of incidence is always equal to angle of reflection. Second, incident ray, comma normal, comma reflected ray lies in same plane. Third, incident ray, comma reflected ray lies on opposite sides of normal. Right. 3 point laws of reflection. Oh, we are getting disconnected.
Yes, sir. Now it's fine. Done, sir.
Light, when passes from one medium to another, at the separating surface, it shows partial reflection and partial refraction means it goes on the other medium. In this chapter, this reflection wala part we are not interested. We are only interested in refraction. That means going in other medium. So what is refraction of light? Actually, both phenomena are taking place. Reflection plus refraction. But we have to study only refraction of light. So whenever ray of light travels from one transparent medium to another transparent medium, it changes its direction. This phenomenon is called as refraction of light. When ray of light travels from one transparent medium to another transparent medium. When ray of light travels from one transparent medium to another transparent medium, then it changes its direction. This phenomenon is called as refraction of light. Write this definition. When ray of light travels from one transparent medium to another transparent medium, it changes its direction. This phenomenon is called as refraction of light. Did it?
Yes, sir.
Yeah, sir.
Okay. Loss of refraction. First, incident ray, comma refracted ray, comma normal, lies in same plane. That means if light is coming this way, then it will fall straight like this only it will go. This way, like this only it will go in one plane. Have you seen waterfall?
Yeah,
Water.
sir.
So it comes from top to the bottom in same plane. It will not come from top and jump to the other mountain. The same plane. Second, incident ray, comma refracted ray, comma normal, comma refracted ray lies on opposite sides of normal. Third, which is very important point to be remembered. The sign of angle of incident, the ratio of sine of angle of incidence, and in maths you have studied trigonometry. In maths, trigonometry started.
Just started, sir.
Okay, so sine means you know, na? It is ratio of two sides.
Yes, sir.
Okay, so ratio of sine of angle of incidence and sine of angle of refraction Pierce constant ratio. That means for two same medium, separating medium like air water, air glass, glass water, this ratio will remain constant. Ratio of sine of angle of incidence and sine of angle of refraction Pierce constant. Refraction remains constant. This constant is called as refractive index of second. Okay, just copy it in this. Ratio of sine I up and sine R is constant, called as refractive index. It's called as refractive index of second medium with respect to first. It is denoted by Greek letter mu. So mu21 is refractive index of second medium with respect to first. Done?
Gotcha.
Okay. When ray of light, there are three cases, travels obliquely from rarer medium to denser medium, then it will bend towards the normal. This is normal I am drawing. Normal, normal. This is ray of light incident. Here also ray of light incident. Here ray of light is incident along the normal. So in this case, if it goes from rarer to denser medium, then it will not follow same direction, but it will bend towards the normal. This is called as angle of incidence, angle of refraction, and this is called angle of deviation. When goes from denser medium to rarer medium, then ray of light will move away from normal. So original ray and refracted ray का बीच का angle is angle of deviation. This is angle of refraction. This is angle of incidence. When light is incident normally, light is incident normally. So there won't be any refraction. It will come out straight without showing any change in the path. So we should have two medium and light should be incident not normally but obliquely. Then only there will be refraction. So if you see in this case, if you are seeing this case, this is that original path. This is normal and this is refraction. So this angle is whole is I. Hello? Hello?
Yes, sir.
Can I say in this diagram I is R plus delta? Can I
Yes.
say I is R plus delta? Look geometrically. This is normal. This is ray of light. So these two are same and this is deviation. So this is R, this is delta, but total is what? I, na? So I is R plus delta. Here, if you see in this case, then R is I plus delta. This much is I. So R will be I plus delta. Here delta is 0 because there is no deviation. All the three diagram followed? Hello? Diagram followed? Second one you have not followed?
Followed.
Okay. So this is the ray of light coming. So this is whole, this much is I by vertically opposite angle. This part is I, moves away. This is delta. So this total is R plus delta, I plus delta. Clear? Hello? Hello?
Yeah, sir.
Yes, sir.
Draw this three diagram.
Done, sir.
Okay. Next, effect on speed, B, wavelength lambda and frequency f due to refraction. What happens to light's speed, wavelength, frequency if there is refraction? If there is refraction means when light is going from one medium to another and changing its direction. Just try heading, then one by one we'll see all the three aspects. See, denser medium means particles are very close, and rarer means they are widely separated. So in this, the light can travel freely, faster. Here, they travel slowly. So when ray of light travels from rarer medium to denser medium, then speed will decrease. And denser to rarer, then speed will increase. This is first effect. When a ray of light gets refracted from a rarer medium to denser medium, then its speed decreases, while if it is refracted from denser medium to rarer medium, then its speed increases. Right, first point. Denser speed decreases, rarer speed increases.
None, sir.
So for speed, going in denser, it decreases, rarer, increases. Denser decreases, rarer increases. Denser decreases, rarer increases. Okay.
Yes, sir.
Second. See, frequency does not depend upon medium. It is source dependent. So the frequency of light depends on source. Hence, it does not changes on refraction. Third point. What is speed formula for wave? Do you know this? Wave v equals to f lambda. Do you know this?
Yeah, so we learned in light last year.
Last year you have done. Where v is the speed of light, lambda is wavelength of light, and f is frequency of light. So from this f equals to v by lambda. So if f is constant and numerator is increasing, then denominator will also increase, then only ratio will remain same to same. Like suppose this is 10 upon 10, answer is 1. If this I want to keep 1 1 1, so when this becomes 20, this also should become 20 or not?
Yes, sir.
So when numerator increases, denominator will also increase, then ratio will remain same. Hello?
Yes.
So we said velocity will change from one medium to another. So wavelength will also change from one medium to another.
Yes, sir.
Okay. So just copy the wavelength wala part we are writing.
Done, sir.
You can say thus when ray of light goes in denser medium, then velocity, comma, wavelength decreases, but frequency remains constant. When ray of light goes in rarer medium, then velocity, comma, wavelength increases, but frequency remains constant. Right.
Done, sir.
Once again, I'm revising what we did till this. What is meaning of incident ray? Incident ray, light which is made to fall on surface is incident ray, which comes back is called as what? Reflected ray. The perpendicular one is called as
Normal.
normal. What is I?
I.
I. Angle made by incident ray with normal. R. Angle made by reflected ray with normal. I is same as R. Then in refraction, there is change in direction. Goes from rarer to denser, then bends towards the normal. And denser to rarer, away from normal. If along the normal, no refraction. Velocity in rarer is more. Wavelength in rarer is more. But frequency is constant. Clear?
Yes, sir.
Define refractive index. Almost every year they ask. Define refractive index. So whenever it is given define refractive index means it is comparative term. Second, we explain with respect to first. Regarding their rarer or denser or optical density. If refractive index is more, that means denser. If less, then it is rarer. Equal to 1, then it is vacuum or air. So see, the refractive index of second medium, refractive index of second medium with respect to first medium is defined as the ratio of Sine of angle of incidence in first medium. 2. Sine of angle of refraction in second medium. It is unitless. That means no unit because it is ratio of two similar quantities. Copy.
Done, sir.
Absolute refractive index. One is only refractive index. This I have written absolute refractive index. Absolute means if somebody is getting 100, if this is my benchmark, then anything more is higher. But sometimes if I compare 50 with 100, sometimes I compare 150 with 200. So they are two different mediums. Absolute means one is fixed here. That is air or vacuum. So whenever one medium is fixed, either air or vacuum, and then when you find the refractive index, then it is called absolute refractive index. So the refractive index of a medium with respect to vacuum or air is called as absolute refractive index. It is denoted by only mu. No need to write 2 1 or 1 2. Copy absolute refractive index. So here it is understood. First medium is air, second may be any.
मैं भरूंगा वो टोल का पूरा मैं टेक में आऊँ मुझे आगे बुलाएगा बोला बोल देना कि गया फुटबॉल गेम खुद आके लेके चलो तो टेक में आएगा क्या
Done, sir.
Refractive index. See, I have written ITO means in terms of speed. Refractive index is in terms of wavelength, in terms of speed, in terms of angle. So refractive index in terms of speed. The refractive index is also defined as the ratio of speed of light in vacuum or air to the speed of light in that medium. So refractive index of medium is also defined as ratio of speed of light in vacuum or air to the speed of light in that medium. Therefore, mu will be speed of light in vacuum upon speed of light in that medium. Right. Written? The speed of
Yes.
light in vacuum we write C and speed in medium we write.
Done, sir.
Yeah, okay. Refractive index in terms of wavelength. So just now we got mu equals to C upon lambda, C upon V. So if I say lambda and lambda dash be wavelength in vacuum and in medium respectively, then Mu can be written as F lambda upon F lambda dash because frequency is same. So can we write lambda upon lambda dash? Hello?
Yes, sir.
So we can say thus refractive index, Ri means refractive index, is also defined as ratio of wavelength of light in vacuum or air to the wavelength of light in that medium. So either it is C upon V or lambda upon lambda dash or sin I upon sin R. These are three formulas for refractive index. Sin I by sin R, C upon V, lambda upon lambda dash. Write down.
Done, sir.
Now I'm doing 4 numericals. Come to page number 82. First numerical. You all have reached to page number 54, 82, numerical wala.
Yes, sir.
Just read.
The speed of light in air
Correct, correct,
is
correct, correct. That means you are perfect. The speed of light in air is denoted by which letter? C. 3 into 10 raised to 8 meter per second. Correct. Calculate the speed in glass. So V in the glass we want. Refractive index of glass, that is mu, is 1.5. We can write this as Vg. This is mu g if you want. What is formula for mu g? C upon Vg or not?
yes, sir.
So can I say Vg is C upon mu g? C is 3 into 10 raised to 8 upon 1.5. So 2 into 10 raised to 8 meter per second. One sum, usually they ask for 2 marks. Very simple sums. Copy.
Done, sir.
The speed of light in diamond. B for speed, D for diamond. Is 12530 kilometer. That means 1, 2, 3, 4, 5. 1.25 kilometer per second. Into 10 raised to 5. Because I have put decimal after 5 digit. 1.25, 1, 2, 3, 4, 5. Into 10 raised to 5 kilometer per second. That will become into 10 raised to 3 more, 1000 meter per second. And what is refractive index of the diamond then? If speed of light in air is 3 into 10 raised to 8 meter per second. Refractive index of diamond is C upon speed in diamond. C is 3 into 10 raised to 8 upon 1.25 into 10 raised to 8. 10 raised to 8, 10 raised to 8 cancel. 300 upon 125. 25 into 5, 25 into 12. So 2.4. Okay?
Yes, sir.
So, see, coming Sunday and coming Tuesday, only Om you are having lecture. Huh?
Yes, sir.
That is chapter number 7th I will complete for you in 3 lectures.
Done, sir.
Third sum. The refractive index of water with respect to air. Water with respect to air. This way we write refractive index of water with respect to air is 4 upon. Then refractive index of air with respect to water is half. Whenever it is interchange, it becomes reciprocal. So reciprocal refractive index of water with respect to air is reciprocal of air with respect to water. Let's see how. If we say water with respect to air, that means it is C upon V in water. If you say air with respect to water, then it will become C upon V. V air I wrote first and then water. So it will become V of water upon C because we wrote ulta. So this is nothing but 1 upon mu of water with respect to air. Okay? Yeah.
Yes, sir.
So this is 4 by 3. What will be this? This will be mu of air with respect to water 3 by 4. 3 by 4 means 0.7.
Done, sir.
Fourth one. A ray of light has wavelength of 5400. This is called angstrom unit. Angstrom unit. Suffers refraction when it goes from air to glass. So this was in air, it goes in glass. Whose refractive index with respect to air is 352. What is wavelength of light in glass? See, refractive index of glass with respect to air. One is C upon Vg, other is lambda air upon lambda G. So lambda, this is 3 by 2. Lambda air is 5400. Lambda glass we want. So lambda in glass will be 2 into 5400 upon 3. That is 2 into 1800. So lambda in glass is 3600. Copy. Completed?
1 second.
Yes.
Done, sir.
So today we'll stop here. Coming Tuesday, you don't have lecture. That means all students are not having lecture.